Yes, I am. Solving two-step equations. So what we did in the previous lesson there was solve each type of one-step equation. You had one thing to undo, either an addition, a subtraction, a multiplication, or a division, to get the variable by itself or isolate the variable. That is the goal in solving every equation. Our goal is to find the value of the variable that makes the equation true. That's what solving means. Okay, so if the order of operations in here, this expression 2 times 5 plus 3, right? You multiply first and then you add. Okay. To undo or reverse these operations, do them in the reverse order. Right. So the order of operations is 2 times 5. Okay, and then plus 3. To reverse this, okay, with an answer of 13, first I would undo the addition and subtraction, subtract 3, and then divide by 5, the inverse operations, subtract and then divide, and come back to the starting point, okay? So when you solve equations, you do the steps in the reverse order of the order of operations. So you undo addition or subtraction first, and then you undo multiplication or division, okay? So the two-step equation, the reason it's a two-step equation is because it has both a multiplication or division and an addition or subtraction. So there are two things to undo. You always undo the addition or subtraction first. The multiplication, which is the most common, divisions are not very common. Normally it's just going to be a number times the variable here. You can't touch this. You can't touch this until it's by itself. Okay, can't touch this until it is by itself. Mrs. Woodruff likes to put a little circle around it. She calls it the Woodruff bubble. And if you have her next year for Math 8, you will hear about the Woodruff bubble when you do these problems. Okay? So don't do anything to this 2x until it is by itself. So that means I have to undo this plus 3 first. Okay? So to undo plus 3, I subtract 3 from both sides, just like we did yesterday in the one-step equation. I show it on both sides. A good trick here is to kind of draw a straight line right underneath the equal sign in your equation. Anything you do on one side, you do on the other side. Anytime you finish those operations, what you're left with is an equivalent equation, an equation that is balanced just like the original one. So if I subtract 3, to undo plus 3, I subtract 3 from both sides. This becomes a 0, right? This becomes 0. And I'm left with the 2x on this side. And over here, 9 minus 3 is 6. These are equal. They're balanced still. Now it's a one-step multiplication equation, just like we did yesterday. To undo, you don't have to rewrite this, okay? You can just add, like, yours will look like this, okay? 2x equals 6. Undo multiplication by dividing both sides by 2. I also don't write this equal sign in here typically, okay? As long as I do the same thing to both sides, that's the balance, okay? I don't write the equal sign in there, even though you could, because minus 3 equals minus 3, but divide both sides by 2. This equals 1. 6 divided by 2 is 3. This is my solution. The value for x that makes this equation true is 3. Now, I didn't make you do checks on one-step equations because I think they're kind of silly. But we're going to check the solution for every problem. Okay? It's one of the beautiful things about algebra is that once you get your answer, you can actually check to see if your answer is correct. You take this number, 3, and you substitute it into the original equation, and you see if the equation is true. Because that's what the solution is, the value of x that makes the equation true. So the check, I do not make you rewrite the original equation in the check. okay? This step I don't require. Instead of x in the original equation, which is right here, I put in 3, the number that I think x is equal to. And notice that this is an equal sign with a question mark on the top, because I'm not sure that these are equal. I am checking it. Now, in the check, you use the order of operations, because I don't have any variables now left, right? So it's all numbers, so I can use the order of operations. You won't see any parentheses or exponents in any of these problems, not till later, and next year, okay? So 2 times 3 is 6, plus 3, okay, on this side. This side is just going to be 9 still, and this side comes out to 9. If both sides are equal at the end, then your answer is correct. Okay, that's what your check should look like. All right, now the little yellow sticky here says, what are the 2 operations you would do to solve 3x minus 4 equals 8? What 2 operations? Tori's all over it, I can tell. Go ahead, Tori.
Addition and division.
Right, you would add to get rid of this minus 4, and then divide to get rid of the 3, right? So add 4 and divide by 3. Those are the 2 steps, which is why these are called 2-step equations. 2 more examples done out in the book. Okay? Two more examples. So 3x plus 2 equals 23. Undo the addition by subtracting. Again, you don't have to write this equation twice here. If your answer is 3x equals 21, then you just do the division right under that. And you get x equals 7. And the check. I'm going to do one of these alone here in a second, okay? Number 3, example 3, negative 2y minus 7 equals 3. Again, the minus 2y is the part you can't touch until it's by itself. Add 7 to both sides to undo the minus 7. You do it to one side, you have to do it to the other side. Then you get, and again, you don't have to write this twice, negative 2y, that's all that's left over here, equals 10. Undo the multiplication by dividing both sides by negative 2. And here's your solution. The value of x, or y in this case, that makes the equation true, I think is negative 5. The book says check the solution, but they don't do a check, right? They just like left it out. So
You have a Mr. Yuck.
I do have a Mr. Yuck, because they said check the solution and then they didn't do it. Okay? Substitute in negative 5 in for y in the original equation. So negative 2 times negative 5 minus 7. Then you use the order of operations. That's 10. Negative 2 times negative 5 is 10 minus 7. Yep, that side comes out to 3. It matches this side. So that means my answer is correct. So we'll check mark at the end. Wow, another one. So many examples. Okay, this example, I apologize, or not really apologize, but the book shows this as 1/5 r. Okay, 1/5 times r. Recognize that 1/5 times a number is the same as dividing that number by 5. Okay, 1/4 x is the same as x divided by 4. 1/2 x is the same as x divided by 2. Okay, and I will show these problems like this, not for you guys, not with a 1/5 x. But you'll see this one like, this will just read x over 5. 4 plus x over 5 instead of 1/5 r. So I'll do one of those in a minute. All right, so there's 3 got it. There's 6 got it problems here, I think, for you to practice. Let's see. Yep. All right. We're gonna do the first one together. Okay, so again, now this is how my work is shown on these problems, not like how the book shows it, but what I want to see. All right, so you start, you don't have to rewrite the equation, right, in your book. If there's enough room, you can just start right underneath there. I'm pretty sure I rewrote the equation. Okay, so 2x plus 4 equals 10. If I need to remind myself that I cannot touch this x thing until it's by itself, I draw a little bubble around it. So my first step in this equation is to undo plus 4, and I do that by doing what, Carlos? Subtracting 4 from both sides. Okay, not just from one side, but from both. Follow along here with this example. If you don't have room in your book underneath it, you can do it in the green work zone on the side, unless you doodled all over it, then you don't have that room either. Or you can do it on a separate piece of paper. Okay? Subtract 4 from both sides. Then this leaves me with 0, right? This is 0, plus 4 minus 4. And 10 minus 4 is 6. So 2x equals 6. Then divide both sides by 2 to undo this multiplication. So I divide both sides by 2. And I get, this now is just going to be, this is equals 1, 2 divided by 2. And 6 divided by 2 is 3. So there's my solution. I think the answer is x equals 3. Check. By substituting 3 in for x in the equation, and I have a little equal sign with a question mark on it because I'm not sure. That kind of tells me, if I'm looking at this work, that that's your check. 2 times 3 is 6. Everything else just stays the same. Then 6 plus 4 is 10 on this side, and the two sides of the equation are equal, which means that my solution is correct, and I'm happy with x equals 3.